practice quiz that I posted for you. So you already have it. I cannot share it at the same time. So I'll have it for myself. So the first question, of course, is the chain rule. Okay, the first one is going to be the chain rule type, which are going to be covered 4 types of function, and 4 of them are going to be given to you. Okay, so let me bring it up here for myself, and then I get this one. Okay, so this is going to be our practice quiz number 3, number 2. Okay, so it's a take-home quiz number 3. Practice quiz number 2. The first topic is going to be the chain rule. Okay, this would cover problem number 1, which would be covering 2 problems on the quiz. So you must know the chain rule formula. Okay, the chain rule. The chain rule formula, you know that if u is a function of x, derivative of u to the n. It's composition of 2 functions, the u function and the power function. The power function is you always drop it down, n, so 1 unit out, u to the n minus 1. That's the power part. Then there is u part that gives you u prime. Okay, so you need this formula to take care of that 2 questions, 4 parts on the quiz and on the next test, and even on the final. This would be given to you on the final. Okay, so this is it, and all the types are here. And we did it before, part 1. The function, the first one is quite a standard one, nothing extra to be done. So it's just 2x to the 5th, okay, plus 4x squared, everything to the 7. So everything raised to a parenthesis must be done with the chain rule. So we can make a formula for yourself. This is like u to the 7. So you remind yourself that if I want to find the derivative of u to the 7, action of the power first, 7u to the 6, and then the u prime. This is not bad to remind yourself of the formula that you have to use. Now you copy the formula. Okay, so the solution is going to be, this is it, f prime of x, the power first, 7, 6, 7, 6, 7, nothing is going to be changed, remember, just the power. So that would be 7, 6, now the u prime. Action of the power and the action of the u. So the u prime, derivative of the inside, you know that's going to be 5 times 2, 10, 10x to the 4th, okay, plus 2 times 4, 8, and that would be 8x, and you're done. No simplification is possible. The only time that we're going to simplify, you see this is a single term, 7. If you get a single term over here or a monomial, you multiply them together. Otherwise, this would be the end of the problem. Any question? So that's a type 1. Type 1, you don't have any other functions other than the polynomial, so it's going to be a polynomial inside and the power outside, and then you'll be done. Okay, that's a type 1. What's a type 2? I write it down in the format of the type that's going to be. The type 2 is this part D. It's a radical function. So it's going to be kx. Okay, kx is your function, and it's 9 root. Okay, it's going to be 9 root of x squared minus 2x plus 1. Radical function. This is a type 2. Now you know that in calculus, we don't like the radical function. So we're going to change it. The index is 9, so this is going to be u to the 9, or whatever is inside. Okay, so you do the rewriting first. This is not, it's just the algebra part. So you change it to the kx is equal to the x squared minus 2x plus 1. Okay, everything to n9. So that's your first action. As soon as you change it, you get back to the part 1. Okay, so the inside is going to be like u. So it's going to be u to the 1/9. You may remind yourself that if I want to find derivative of u to the 1/9, okay, again, the power first. You bring the power down, it's going to be 1/9. U to the 1 dot. Is 1/9 minus 1? Is going to be 1 minus 9. 1 minus 9 would be -8. -8/9. So that's a power part. But you pay for it, u prime. You see, you build up the formula, now you copy the formula. So bring it here. That's going to be k prime of x is equal to the power first, 1/9 u to the -8/9. 1/9, okay, x squared minus 2x plus 1, everything to the -8/9. Now you have to pay for it, u prime. U prime derivative of the inside times it by derivative of the inside, you know that, just the power rule. Derivative of x squared would be 2x minus derivative of the 2x is 2. 1 times 2, 2. And that is the end of the problem. Okay, so it's the same case if you like. But your power is going to be a rational number, a fraction, because you have to change the radical into the 1/9. Any question? So that's a type 2. You got to be careful when you're dealing with a fraction here. You see 1/9 minus 1 is like 1 minus 9, which is a -8. So it's a -8/9. -8/9. The power, then you have to multiply by u prime, which is the derivative of the inside, and then you're done. No simplification is possible. All you're required to do it. Okay, any question? That's type 2, the radical function. Now what's going to be type 3? Type 3, it's a little bit more involved because the type 3 is going to be a product and the chain rule. Okay, so that takes us to the part B. Part B, the function is g of x equal to, you have a 5x squared. Okay, 5x squared times it by the 4th root. Okay, the 4th root of x to the 5th plus x squared plus 1. Okay, that's going to be your function. For this function, you have an extra job. The extra job is this radical. Okay, so we change the radical. Sometimes it may be given without radical, but we are ready for it. Okay, so change the radical first for this one. So what we are going to be having is g of x is equal to, we get the 5x squared here. Okay, then you change the radical. So it's going to be x to the 5th plus x squared plus 1, everything to a quarter. Okay, so it's either given to you like as a product right away, or you may have a radical in between that you take care of it. Now, the format is going to be the product of two functions, because the first function is a 5x squared, you see, and the second function is this one. So basically, you have to consider this one as a product of two functions. Remember the first times the second. So your formula for differentiation is going to be the product rule. Remember the product rule is going to be derivative of the first one, which is f prime, times the second one, which is s, plus derivative of the second one, s prime, times f. So that's the main formula that you have to apply. But you see, derivative of the first one is easy. It's a 5x squared, so it's ordinary differentiation. That give it 2 times 5, 10, 10x. That's the derivative of the first one times by the second one times the second plus the second first. You see the second one is a U type. The second one is something like U to a quarter. So for the second part, you have to use the chain rule type. Okay, so that's a model format of this problem. One of the function is ordinary function that you can differentiate it right away, but the other function is going to be U function, if you like. Okay, so we apply the product rule first. So that's it, G prime of X. G prime of X is equal to derivative of the first one, 2 times 5, 10, 10x. That's the derivative of the first one. Times the second, times x to the fifth plus x squared plus 1. Okay, everything to a quarter. So that's the derivative of the first times second. Any question? No. The second part is tricky, plus derivative of the second one. Second one is the chain rule type. Parentheses raised to something. You remind yourself, you may remind yourself, oh, so what I need is this formula. You need a quarter, okay, derivative of a U to a quarter. So the power first is going to be a quarter. You don't have to write it down, of course, on the test, but we just remind you. So it's going to be a quarter times U to the 1 down, a quarter minus 1, 1 minus 4, which is a negative quarters. Okay, then times the U prime. So you remind yourself that if you want to find the derivative of the second one, you have to apply the chain rule. So the chain rule would be the power down is going to be a quarter. Okay, x to the fifth plus x squared plus 1 to the a quarter minus 1, which is going to be negative 3/4. Times U prime. U prime derivative of the inside. Derivative of the inside would be what? Would be 5x to the fourth plus 2x. That's the derivative of the second one. Okay, so this is the derivative of a second function. But you have to multiply by the first function. What's the first function? 5x squared. So times it by 5x squared. Okay, any question? So it's the product rule first, derivative of the first times second, plus derivative of a second times first. First is just 10x. 2 times 5, 10, 10x.
Where did you get the 5x squared again?
Derivative of a second times first. You see, let me finish it. Is derivative of the first times second. You see, first times second, plus the second times first. Okay, so this is the first times second. Second is U type. Okay, so it's going to be a quarter, U to the negative quarter times U prime. This is the second. And the first, derivative of a second times the first is 5x squared. Okay, this is it, S prime times F. Any question? But you're not done because we have a single term here. You see, you have a single term 5x squared and you have a quarter. You have to multiply these two together, okay? If it's going to be anything inside the parentheses, you'll be fine. But outside you multiply it, it's like 5 times a quarter would be 5 quarters. So you have to rewrite all of them. So you get to this part, you get the G prime of X is equal to, the first part is going to be unchanged, going to be 10x times x to the fifth plus x squared plus 1 to a quarter. Okay, that's going to be the first one, but now a quarter times 5, that gives you 5 quarters. Okay, 5 quarters x squared. X squared and the rest is going to be x to the fifth plus x squared plus 1. Just repeat it. Negative 3/4 and times it by 5x to the fourth plus 2x, and then you're done. Any question? So keep it simple, don't make it complicated. It should be fine and should be able to, okay, to go through it. So this is the one we call it. It's a type 2 really. You have, or you can say that, the type 3 here. So it's a product and the chain rule. It's a product because this is a product of two functions. And the chain rule, you need the chain rule for the second part. Because one of the derivative is ordinary derivative, which is a 10x. But the other one is going to be parentheses raised to something. So it's clear that you have to apply the chain rule. Any question? So that's a type 3. And when it's come with a radical, this is the most general one, if you like. Now, what's going to be the next one? The next one is the chain rule and the quotient. Okay, so that will take us to the part C. Part C. Part C is this one is h of x is equal to, it's going to be equal to the 3x to the 4th. Okay, minus 5x and divided by 5x cubed plus 1, everything to the 8. You see, that's going to be the type 3 that we talk about. You see, you can use the quotient rule if you like, derivative of the top times bottom, bottom top. But my recommendation is, I talked about it the other day, if there is no power here, you see, if this is going to be the case, this is the only time in this course that you are going to use the chain, the quotient rule. Derivative of the top times bottom, bottom top. Otherwise, move it up. When you move it up, it's going to be product. And then you can simplify it. Okay? So the only time that you use the quotient rule is this one. You see, it's the ratio of two functions. Derivative of the top times bottom, bottom top. But if there is any power, move it up. Okay? That makes things so easy for you to do it. Unless you want to stay with the quotient rule, because the result of the quotient rule must be simplified all the time. So to simplify this type of function, there are quite a lot of algebra involved. But if you move it up, it's already been simplified. So you don't have to be worried about the last part of your problem, okay? So I'm going to rewrite it. So there you are, rewrite, you know that you move it up. That's going to be h of x. You open up a parenthesis for the top one, 3x to the 4th minus 5x. Now you multiply by 5x cubed plus 1, everything to the negative 8. You see? Now it's going to be a product of two functions. And we already done this one. We can easily, apply the product rule. Again, derivative of the first times second would be ordinary differentiation. But for the second times first, it's like u to the negative 8. You have to apply the chain rule. Okay, so when you move it up, you don't have to memorize different patterns, different models. It's just two models. Model of u to the something and the product rule. That's it. If you get a fraction, rational function, change it, move it up, and then you change it, and then you'll be able to do it. Okay, any question? Now it's just reminding ourselves that we have to consider the product rule. Derivative of the first times second, second first. Okay, so there you are. It's going to be h prime of x equal to derivative of the first one. Easy. Go inside, differentiate the power rule. 4 times 3 would be 12. That gives you 12x cubed. Okay, minus times 5. 1 minus 5 would be 5. So that would be derivative of the first one. Any question? Times it by the second one. The second one, 5x cubed plus 1 to the negative 8. That's the derivative of the first times second. Now the second first. Second one, you have to go to the u to the negative 8. You remind yourself, I need to find this u to the negative 8, differentiate it. Remember, power down, negative 8, u to the negative 8 minus 1, which is a negative 9. Times it by u prime. Okay, so you just remind yourself the formula that you want to use. It's just u type. Now you copy this formula. If you copy it here, it's going to be what? Derivative of a second one. Bring the 8 down, negative 8, 5x cubed plus 1 to the 1 down, negative 9 times u prime. U prime derivative of the inside. 3 times 5 is 15. 15x squared. Okay, so that would be derivative of u to the negative 8. But you have to multiply by the first one. You multiply by the first one, which is going to be 3x to the 4th minus 5x. Exactly like, the previous one that we did over here. So it is going to be a product of two functions. Derivative of the first, I repeat it again, 3 times 4, 12, x cubed, minus derivative of the 5x times 1 times 5, negative 5. That's derivative of the first function times the second function, as is. Now, the second verse, the second is chain rule type, u to the negative 8. You bring the power down, negative 8, u to the negative 8 minus 9, minus 1, negative 9 times u prime. So negative 8, 5x cubed plus 1 to the negative 9, times u prime, derivative of the inside, 15x squared, times it by the first. Okay, any questions? So what's question? And then you are not done because you have one monomial over here, and then you are going to get this is going to be
So
the
do
one.
you not add the additional sign
Additional sign where?
in that equation? Because aren't we doing the FS with the
Yes.
one? Where'd you put the additional sign in this equation?
No, you see, because you have a negative sign here, you see, negative positive would be negative.
Okay.
If it's going to be plus, you see, if it was a plus, that is still plus here. Okay, but automatically, because this is a negative 8, when you break it down, yes, your original sign is positive, but you have a negative here. Okay, so negative positive would be negative, and that give you the result that you're going to have. Okay, so we are not done. Let me finish it, then I get back and answer your questions. You're not done because there is a monomial here, you see, and there is a monomial here, a single term. So you have to put these together. So I'm going to put them together in multiply, you see, negative 8 times 15. Negative 8 times 15 would be what? Would be something like 120, yes. That's going to be 120. So your final answer would be h prime of x equal to, okay, h prime of x would be equal to the what? 12x cubed minus 5, repeat it, 5x cubed plus 1 to the negative 8. Now this is going to be minus 120 x squared. Everything else would be unchanged. 5x cubed plus 1 to the negative 9 times it by 3x to the 4th minus 5x. That's the best format. If you do the quotient rule, you'll be very much in trouble to get these numbers. Okay, so this is going to be the case. No, if you get the radical, you see that the previous one that I did, the fourth root, you get a quarter. But this problem is different from the other one. You see, it's a quotient. If anything is down the denominator, you just move it up. You just change the negative sign of the power. So that make it to the negative 8. If it's going to be radical function, you see we give you the formula before, then you have to write it down as a fraction. How did I get negative 120? I multiply this together, you see. Negative 8 times 15. Negative 8 times 15, that gives you negative 120. And of course, you have the x squared here. Okay, so we get negative 120 x squared and the result here. Any question? So this is, we just try to make it, okay? We try to make it as easy as possible so that we are not going to worry about it. Okay, so if we get in order, you can try it for yourself. Sometimes people, they do they do the quotient rule for this one. It's going to be quite a long fraction for the quotient rule. But just stay with this method. Even in your book, they ask you to use the quotient rule. You can ignore it because in the second part of the course, we are going to have something else. We call it integrations. And you have to do this type of ideas or the ideas into these type of functions. So if you stay with the one rule, you'll be fine for the second part of the course. Otherwise, you'll be confused. So if I give you a rational function and I ask you to differentiate, you look. If there is no parenthesis here, quotient rule. Lift up the top times bottom, bottom top. Okay, but if any power, 2, 3, 4, 5, 6, a quarter, fifth, you move it up first. You move it up, okay, you make it into a product, and it's easy to remember. So we have only two types of chain rule, if you like. One is just the power rule type, and the other one is going to be the product. Okay, any question? You have one more. I just put all the possibilities for you, really, so that you get it. The other one is the same thing, but we have the radical at the same time. Okay, let's try that one too. So you get the two questions, 4 parts. We give all these 4 types of functions. This part E is just a quotient again, but there is also a radical involved. Just to make sure that you get this one right. So your function is f of x equal to 7x. Okay, 7x, and this is the square root of 5x plus 1. Again, you know that you have to change the radical and you change the fraction to be able to do this problem. So what you're going to do, you have to rewrite it. Okay, so the solution is going to be, this is how you rewrite it. This is f of x equal to, that is x. You change the radical, you know that the index is 2. So it's going to be 5x plus 1, 5x plus 1 to a half because of the square root. Now we get a fraction that we don't like it, so we move this one up. So it's going to be equal to x times 5x plus 1 to the negative half. You see? We change it nicely to an easy function to differentiate, okay? So this is going to be your function to differentiate. X times 5x plus 1 to the negative half. Any question? No, you know that it's a product of 2 functions.
What happened to the 7 in the numerator?
Oh, 7, I missed it. Thank you. 7, 7, 7, thank you. Okay, it's a 7x, thanks. Okay, so it's a product of 2 functions, okay? And the first function, as you can see, it's going to be 7x. It's going to be the first and the second. So it's just a type 2 again. So we have to apply the product rule. Derivative of the first times second, easy. Derivative of 7x is 7. But when you want to do the second first, is the chain rule type. It's u to the negative half, okay? So this is going to be the result. F prime equal to derivative of the first one, 7x with just 7, times the second one, 5x plus 1 to the negative half. Okay, that's the derivative of the first times second. Any question? Now the second first, it's a u type. Remind yourself that you have to apply the u to the negative half for the second part. It's always the case. So again, the power first, negative half, okay, u to the 1 done, negative 1 minus 1. It's like negative 1 minus 2. Negative 1 minus 2 would be negative 3. So that gives negative 3 half times the u prime. Okay, so that's the chain rule part for this one. So we continue. Since it's a negative, you see, you just start with the negative half. Is going to be negative half, derivative of the second. Negative half, u is 5x plus 1 to the power down, negative 3 half times u prime. U prime derivative of the inside one, derivative of 5x plus 1. Derivative of the 5x plus 1 is simply 5. So that would be the derivative of the second one. Any question? Now the derivative of the second times the first one. So what's the first one? The first one is 7x. Don't miss it, 7x. Again, you have monomials quite a lot. You see, 1, 2, 3. You have to multiply these together. Okay, so 7 times 5 would be 35. 35 times 1. So this is going to be how you write the final answer. F prime of x equal to, it's a 7 times what? 5x plus 1 to the negative half. Okay, and for the rest, the sign is going to be negative. And as we talk about it, 7 times 5, 35. 35 times 1 would be 35. Is the 35 half? Half of x. Half of x times it by 5x plus 1 to the negative 3 half. That would be the final answer, or the best form to write your final answer. Any question?
The U is always inside the parentheses.
That's it, yes.
Okay, thank you.
Yeah, because U is something other than the X, so we take the inside parenthesis to be U. And as soon as you see a parenthesis raised to something, you have to apply the chain rule. You have to take that U to be able, that's one indication that how we get, you get the one. You see, this is it. I apply, I repeat it again, derivative of the first times second, derivative of 7x7 times second, done. Now derivative of the second times first. Second is U to the negative half. You see derivative of U to the negative half, you bring the power down, negative half, U to the negative half minus 1. It's a negative 1 minus 2 would be negative 3 half times U prime. Now we copy this formula, you see. That's it, negative half, U is 5x plus 1 to the negative 3 half times U prime. U prime is derivative of the inside. Derivative of the 5x plus 1 is 5. So that's the derivative of the second times the first function. The first function is 7x. Okay, because it's a product rule. Now you have to take care of these numbers. So you have 5, 7x, you multiply them together. 7 times 5, 35 times 1 is going to be negative 35 half x, and that gives you the final answer. And no other simplification is possible, or you are going to be required to do it. Okay, so any question? So it's a kind of, this is the most involved one from algebra point of view. So you have a similar one in your take-home one. Just check those to get there. So it's the 4 types of function to differentiate, and we give all the 4s. Okay, that was topic. That's topic number 1. Any question? Now, what's going to be topics number 2? We want to check because we didn't check the quotient rule. Okay, so our excuse are going to be this question number 2. We are going to check we give you 2 problems on the tangent lines. And this is the first one, horizontal tangent lines. We already talked about it, how we're going to get the horizontal tangent lines. If a line is horizontal, the slope is 0. But this is calculus. The slope is f prime. So if you want to find out whether you get the horizontal tangent line or not, you have to solve the equation of f prime of x equal to the 0. So we wanted to do it for us, but the functions are going to be rational functions, and for the derivative, you have to go with the quotient rule only. So that's the topic of this number 2. So the number 2, we are interested in what? Horizontal tangent lines. And we already talked about it. You see, this is a tangent line. When it's horizontal, the slope is 0. But the slope is f prime of x. You see, that's it. So in order to get the horizontal tangent line, your f prime must be equal to the 0. So for these problems, whatever you are going to do for us is you just find the derivative of the function and you check to see when those derivatives are going to be equal to the zero. And the function is going to be rational functions because we are going to see this type of function quite a lot. Okay, there are just a couple of cases and they are almost the same. So let's try, we just run your algebra here. These functions are going to be used in future quite a lot. So that would be x squared over x minus 2. That's the first one. You want to check if you have horizontal tangent line. So what you have to do is, you see, you have to solve this equation. Solve that solution. Equation of f prime of x equal to the 0. Because the slope must be 0. The slope is derivative. You see, there is no parenthesis here. You see, there is no parenthesis. So if you want to differentiate this function, you are not going to move it up because there is no power. So you stay here and use the quotient rule for all these examples. So reminder the quotient rule, remember derivative of the top over the bottom. That's it. If you want to take this derivative, it's going to be the derivative of the top one, t prime, times it by the bottom one, b, minus derivative of the bottom one times top, derivative of the bottom one, b prime, times t, divided by the b squared. So this is the formula, because we didn't have it for the previous problem, so we are going to check it here. Okay, any question? There you are. Differentiate, use this formula. Then you let it equal to 0, solve for x, and then you're done. So let's differentiate. That's it, f prime of x equal to derivative of the top, derivative of x squared is simply 2x, 2x, times bottom x minus 2, minus derivative of the bottom one. Derivative of the bottom one is 1. Derivative of x is 1 times top. So I just write it down so that you know that we did it. So it's going to be negative 1 times the top, x squared, divided by the bottom squared, x minus 2 squared. Any question? So the derivative of the top, 2x, times the bottom function, x minus 2, minus the derivative of the bottom one, derivative of x minus 2 is just 1, times top, divided by the bottom square. Now you have to distribute the top, do the algebra. Sometimes you may have to use the FOIL method to simplify it. So we're going to continue on the top. You distribute this one, 2x times x would be 2x squared. And you multiply this one, that you negative 4x. And over here is going to be 1 times x squared, negative x squared, over x minus 2 all squared. Continue, combine the like terms on the top. So it's going to be equal to, you have 2x squared and 1x squared. You subtract it, 2x squared minus x squared. That gives you x squared. Okay, x squared minus 4x. Minus 4x divided by x minus 2 all squared. So that would be f prime of x. F prime of x is equal to x squared minus 4x divided by x minus 2 all squared. That's the f prime. And that's our purpose, just to check to see if we can apply if we can apply the quotient rule for us, nicely to get your result. Okay, any question? Now let it equal to the 0. So f prime of x equal to the 0. F prime of x equal to 0, the fraction would be 0. X squared minus 4x divided by x minus 2 all 0. You know that a fraction is 0 only if the top is 0. A fraction 0 divided by any number would be 0. So you let the top to be equal to 0. So the conclusion would be the top must be 0. Now you solve this equation by factoring. Sometimes quadratic formula, sometimes factoring. Over here, we have a common factor. The common factor is x. We have to solve it So that gives us x times x minus 4 equal to the 0. So either x equal to the 0, one solution, or the second one is 0, x minus 4 equal to the 0. That gives you x equal to 4. So you can have, okay, you can have two horizontal tangent lines. One of them would be as x equal to the 0, and the other one would be as x equal to 4. When we get to the next chapter, these numbers are very important because one of them give you the maximum, the other one get the minimum. So we call them critical values in future. In future, we use this notation, not now, but you can use it if you like. Critical values are going to be 0 and 4. So these are going to be where you are going to get the horizontal tangent line. This is very important. We just want to make sure you know algebra, how we're going to do it to prepare for the future. This is going to be just the first part of the whatever you are going to do for future. Okay, so it's a straightforward. The derivative is easy. It's a quotient rule. Derivative of the top times bottom. The top, you see. Derivative of the top 2x times bottom minus derivative of the bottom times top. Derivative of the bottom is 1. Make sure you don't use these parentheses. The bottom is squared. You have to do the algebra on the top. You have to simplify it. So I just distributed 2x squared minus 4x. Okay, combine the like terms, 2x squared minus x squared. That gives x squared minus 4x. So when you simplify it, you want to make it 0. A fraction is 0 if only the top is 0. Nothing to do with the bottom. Okay, you know that. You cannot have the bottom and the top to be 0 at the same time. So you let the top equal to the 0. This is an equation. It usually can be solved by factoring method. In this case, we factor out the x, so we get two solutions. You may not get any solution, or you may get one solution, two solutions, depend on the resulted equation. So in this case, we have two solutions, and then we're done. Okay, so what is the question? That is going to be the case. That's it. Yes, I factor it. That's it. Okay, you let the top equal to the 0 because a fraction is 0 only if the top is 0 for the fraction. Or you can cross multiply if you don't believe it. You see 0 is like 0 over 1. If you cross multiply, you see x squared minus 4x times 1 would be x squared minus 4x. 0 multiplied by anything would be 0. So it's another interpretation for this result. Okay, let's do a couple of more of these. They are all the same. We give you a fractional one. One of them is only different, but the other one are going to be all the same. So I do one more. The other one, which is different from this group, is part C. It's a very popular case. This type of function is going to be quite a lot. We talk about it. So the part C is f of x is equal to, it's going to be equal to the x squared plus 16 over x squared. The format of the function is different, but there are many, many applications of this form. Okay, the same thing. You want to get the horizontal tangent line, so you have to differentiate it. Since this is a single term, you see x squared, the suggestion is you can move this one up. We already talked about it. If there is any problem, we move it up, okay? So that will help you, not only for this problem, also for future. You don't need you can use the quotient rule again for this one, but it's easier to change it, okay? Just for this group. So you rewrite it. That gives you x squared. You move the x squared up, so that gives you your function. You see, it's going to be easy function to differentiate. Okay, differentiate it. You don't need any rules. Nicely, the power rule give you the result. Derivative of the x squared is 2x. And over here, negative 2 times 16 would be negative 32. Okay, x to the 1 dot is a negative 2. Negative 2 minus 1 would be negative 3. You see, it's going to be left right. Any question? Now, the way you are going to solve this equation is interesting We let it equal to the 0. So f prime of x equal to the 0. Then you have to solve this equation. Look at this one. 2x minus 32 x to the negative 3 equal to the 0. Now, since you want to do this equation, you know that in algebra, you have to change the power first. You have to change it into the positive power. So we rewrite it again. It's going to be 2x minus, okay, we get a fraction. We put the 32 on the top, and we bring down the x cubed. This is the way you solve these equations in algebra. Okay, so I move it up to make it easy to differentiate. Then when I let it equal to the 0, then I get back and change the power into the positive form. Now you have to solve this equation. You know that in algebra, if you want to solve this equation, you have to get rid of the denominator. One way to do it is multiply both sides by x cubed, or if you move it to the other side, you can cross multiply. So 2x equal to, that's a 32, and that is going to be x. Okay, and just checking, yes. So that's going to be 2x equal to the 32 over x cubed. Okay, now cross multiply. If you cross multiply 2x times x to the 4, 2x times x cubed would be 2x to the 4 equal to 1 times 32 would be 32. Okay, this is the way you get rid of it, or you can multiply both sides by x cubed. It's going to be the same thing, you know, that x cubed times 2x would be 2x to the 4, and you get a 32. Now divide by 2, so for x, so that gives x to the 4th equal to the 16. And then you have to take the 4th root to find your x. So we take the 4th root, and that's going to be the 4th root, and this is going to be the 16. Now you got to be careful over here because it's even power, if you like. So your x would be equal to the, you know that 16 is 2 to the 4th. 2 times 2 times 2 times 2 would be 16. So your x would be positive negative 2. So you are going to have two solutions over here. Okay, because the power is 4. You know that if you reduce it, you have to use the absolute value again. If you like, I can rewrite it for you so that you can see it. It's going to be absolute value of x equal to the 2. And then x would be a positive negative 2. If it's odd power, you get only one solution. But when it's even, we get two solutions, positive and negative. Okay, so this group is the version of the derivative is a little bit different. Okay, because I just moved this one up, then I simplify it to get these numbers. There are a couple of application problems in future that you will see this type of the function. Okay, any question? So the rest are going to be the same thing, you know, like the previous one. So if you get time, I'll come back and give you a couple of more of these groups. But all of them are the same. Okay, that was because the part B, D, and the G are all the same. Just use the quotient rule and get the derivative of these functions. Okay, so that's topic number 2. Any question? So this is an excuse to apply the quotient rule because you didn't apply the quotient rule for the other problems. Okay, so we wanted to do it, and we just give you problem of the horizontal tangent line. So that was topic number 2. Topic number 3 is equation of a tangent line, of course. Okay, this is going to be equation of a tangent line. You did it before. If you want to find the equation of a tangent line, you need a point and the slope. And the point is easy to find because the x would be given to you. You just get the y like in your previous test. But for the slope, you have to differentiate. So we are going to be interested in 2 types of function for this problem. One of them, the function is going to be the chain rule type, mostly a radical function. And the second part, the function would be a quotient function. So you have to use the quotient rule. Okay, so that's excuse for these type of problems. Okay, let's do this one first, number 3. So this topic is going to be equation of tangent lines, okay? That's it, equations of tangent lines. That's it. You know that the formula is this one. Y minus y1 equal to the m times x minus x1. So you have to find the slope, okay? The slope is derivative of the function. You know that the m, if you like, is f prime of x or f prime of x1. So for these problems, what you have to do is you need a point, which is going to be x1 and the y1. This is a point. And you need the slope, which is the m. M should, you should find the m just using the derivative of the function. And there are 2 possibilities, okay? So let's take the first one. We give you one radical function and one rational function. For the radical function, you have to apply the chain rule. For the rational function, you have to apply the quotient rule. See, we're just checking in all these problems, we're checking the chain rule and the quotient rule. Okay, so the first one is a radical function. F of x equal to, you have a number of the radical function in your assignment, so you get one on the test, on the quiz. You want to find the equation of a tangent line at the point with the x equal to, okay, a -1. They give you a nice number so that you are not going to end up with a, with a radical number or irrational number. Okay, so we need a point first. It's a 2 steps problem. Solution. Step 1, where is the point? You see, where is the point? I'm sorry, I read this wrong. Where is my point? The point x is given. You substitute to get the y, okay? This is it, you put x equal to the -1 into a function, so that give f of -1, which is going to be equal to the cube root. Okay, it's going to be 3 times a -1 plus 2. So it's going to be cube root of -3 plus 1 plus 2 is a cube root of a -1. Cube root of -1 would be -1. Because -1 times -1 times -1 would be -1. Okay, so we have a point. So what's going to be the point? The point is -1 and -1. This is the point. Any question? Now we need the slope. The slope is the derivative. Okay, so we go for the slope. The slope is the derivative, f prime, at what? At x equal to -1. So you have to go and find the derivative of the function. In this case, is the radical function. We rewrite it. It's going to be 3x plus 2 to the 1/3, which is like u to the 1/3, and we have to apply the chain rule. Okay, that's the rule of this problem. The second problem is going to be a rational function. Then you have to apply the quotient rule to get it. Okay, so that's a topic of this one. So let's work on the derivative of the function. So what you have to do is we have to rewrite the function first. F of x equal to, we rewrite it as a 3x plus 2. Okay, everything to a 1/3. Now we differentiate it. Remind yourself that you want to differentiate what? U to the 1/3. Again, power first, 1/3. U to the 1/3 minus 1 is like 1 minus 3, which is a -2/3. But you have to multiply by u prime. Okay, so copy this formula. So what's going to be f prime? F prime of x is equal to, we bring the 1/3 down, we just copy this formula. 1/3, 3x plus 2 to the negative 2/3. But times what? Times u prime. U prime would be 3. Okay, but we can simplify. You see, 3 and 3 would be simplified. So what are we going to have? That will give us a 3x plus 2, everything to the negative 2/3. That would be f prime. Any question? So you have to apply, you see, it's chain rule again. You have to apply the chain rule to get this one. Now plug in x equal to -1 and carefully simplify. F prime of -1 is equal to, substitute here, you see x equal to -1, that gives you -3. It's like the one that you simplified before. So that gives you a -3 plus 2. Okay, to get to the negative 2/3. So the inside would be a -1 to the negative 2/3. You see, we talked about the other night how we're going to do it. So you can do the 1/3 first. You see, this is going to be -1 to the 1/3 first, then you raise it to the -2. That's easier. -1 to the 1/3 would be cube root of -1. You already got it. It's a -1 here. Okay, so that gives you a -1 to the -2. Now, -1 squared, that gives you a positive 1. And it's going to be a positive 1. If you like, you see, you do the -1 square first, then the -1. But the -1 square is just 1. So the result is going to be 1. 1 raised to the -1 would be 1. Okay, you can do it quickly. Even the calculator will give you the result right away. But you can check it. We give you some nice number, then you'll be able to take it out of the radical. Okay, so f prime of -1, f prime of -1 is equal to 1, which means the slope is 1. Okay, so the slope is 1, and this is the point. Nicely, we can write the equation of a tangent line. Any question? So you got to be careful. Most of the people, when they differentiated, they missed the u prime here, that 3. Then the numbers getting complicated, if you like, or confused. So make sure you did it right. So you copy the formula. Always write the u formula first for yourself. You see u to the 1/3. We bring the 1/3 down. 1/3 u to the 1 down. 1/3, -2/3 times the u prime. So the u prime in this case was 3, which was very helpful. Intentionally, they give you something to simplify. So these 3 and 3 cancel out. And then the result was, easy to handle, to get there. Okay, so you're not done. Now we need the equation of the line. So I'm going to go to the next page and get it. M is 1, P is the -1, 1. Okay, so and this is it. M is equal to 1, and the point P is -1 and -1. Now we are ready to give you the equation of a tangent line. This is x1 and the y1. And this is your formula. Y minus y1 equal to the m times x minus x1. Now you simply substitute y minus y1, y minus y1 is a -1, -1. M is 1, 1. X minus x1, x1 is also a -1. Okay, you simplify, negative would be positive, so that gives y plus 1. And over here is going to be 1 times x plus 1. So that will be y plus 1 equal to the x plus 1. You solve for y would be x plus 1 minus 1. So y equal to the x is going to be the equation of the tangent line, or for the given function.
Can you move it up a little bit, please?
That is going to be the case. Okay, it takes a little bit time to do it for the chain rule type. For the rational function is going to be easier because you use the quotient rule, but it's not bad. You can be able, should be able to do it. You have quite a lot of this in your assignment. All the nearly, I just check, about 2-3 problems on your assignment are all radical function that you have to go through the derivative of a function and getting the chain rule. So that's why I just put this one so that I can practice to get these numbers. Okay, so that was the part one of this problem. The part one, the function was a radical function. There is also part two. So we may give you both of them or we may give you one of them. So you are going to be ready for it, okay? Both of them would be too much, but we just learn it and then be ready for it. So let's do the part two as well. So the 3b, the other possibility, the function would be a rational function in this case, f of x equal to, again, you have two nice one in your take-home one, you better practice those. So you want to get the tangent line at this number, at x equal to -2. Okay, the procedure is the same. We need a point and the slope. For the point, we simply substitute. We substitute x equal to -2 to get the p. Then for the slope, we need the derivative. Derivative, you have to apply the quotient rule, okay, to differentiate it. And derivative of this function is easier because you don't have to use the chain rule. Okay, so this is it, solution. I need a point first again. So I have x equal to -2. Substitute f of -2. It's going to be equal to, it's going to be equal to the -2, substitute 2 times the -2. Okay, -1, and it's going to be -2 plus 3. You go on the top, it's going to be equal to -4, and this is going to be -1, and this is a +1. So that gives me -5/1, which is a -5. Okay, so your point is going to be, the coordinate of the point is going to be -2, -2, -5. So that would be the point. Any question? So just check those operations, make sure you get it right. Now we need the slope. So where is the slope? Again, you know that the slope is going to be the derivative. So m is going to be derivative of the function at what? At a -2. So this is going to be our slope. So to find the derivative of the function, we apply the quotient rule this time. You see, this is going to be your function. The quotient rule, derivative of the top times bottom, bottom top. Okay, so there you are, f prime of x is going to be equal to, get a fraction. Okay, now the derivative of the top one, derivative of the 2x minus 1 is simply 2. Times the bottom one, which is x plus 3, minus. Derivative of the bottom one is just 1. Times the top one. Open up the parentheses, 2x minus 1, divided by the bottom square, x plus 3, all square. Okay, so the difference between these two problems is going to be that for the other problem, you have to apply the chain rule, but for this problem, you just apply the quotient rule. Now go on, simplify the top. You have to simplify it first, then substitute. So it's going to be 2x plus 6, and it's a minus 2x, negative would be positive, plus 1. And that's x plus 3 all squared. Combine the like terms, the 2x and the 2x would cancel out. 6 and 1 would be 7. So that would be 7 over x plus 3 all squared. Okay, so it's going to be our f prime of x. F prime of x is equal to the 7 over x plus 3 all squared. Any question? You have to simplify it, remember. Now you put x equal to -2 to get this slope. So what's going to be f prime of -2? It's a 7 on the top. -2 plus 3 all squared. So the top would be 7. The bottom one is a -2 plus 3, which is 1. 1 squared. 1 squared is 1. So that gives you 7. So this means the slope is going to be 7. Any question? So quotient rule, simplify, then substitute to get the slope. Now we have the slope and the point, we write the equation of a tangent line. So the point is a -2 and -5. So equation of a tangent line, y minus y1, y minus y1 is a -5, equal to the m7 times x minus x1, x minus and -2. You have to simplify that, give y plus 5. And you simplify the inside, it's going to be x, negative, positive, so that will be a positive 2. Okay, distribute the 7, y plus 5. And that gives you 7x plus 14. Subtract the 5 to get the final answer. Y equal to the 7x plus 14 minus 5. Combine the like terms. That gives you 7x plus 9. This would be the equation of a tangent line. Okay, so this is two famous problem of the tangent line problems, which is quite a nice one, application of the derivative, especially the second one, we just use the quotient rule. But the first one, you have to use the chain rule, okay? So be prepared for one of them. Yes, what's the question?
So when it comes to the tangent line, is that the only time we'll use the quotient rule?
Because the function is, yes, yeah, because this function, you see, the function would be a rational function.
Okay,
And
so
then-
that's the only time we'd use the tangent.
Yeah, you are not
Okay,
gonna
when it's
move it.
a fraction.
Yeah, you don't move it
Okay.
up because it would be complicated.
Okay,
Yeah, that's an
you.
excuse so that we can check your quotient rule. Because for all the other one, you just move it up to get those numbers.
Okay,
Okay,
thank you.
that's the one. Any more question? What's question here?
Yes, it's like from let me see this, 3B and A, no, so not A, 2,
Yeah, that's the
2C.
3B.
2C compared to 3B. How come sometimes you arrive to like an actual value, whereas sometimes you have like kind of look like an equation? I'm sorry, that making no sense.
What is your question? You see that the problems are quite different
Mm-hmm.
because in these problems, you are going to find the equation of a tangent line. So for the equation of a tangent line, you need the slope. The slope is going to be when you find the derivative, you have to substitute x equal to -2 to get the slope. But in the problem number 2, you are interested in what? Horizontal tangent line.
Okay.
Horizontal tangent line, you have to force the slope to be 0. So
Oh,
two different problems.
I see.
Okay, we
Okay.
can have a break now.
Thank you.
Okay, then we come back and we just relax and give you two application problems first, okay, to see how far we can go. Those two problems are going to be easy, but we are going to use it from now on. So we check it right away. So in future, you are going to have it in any test we bring them here. Okay, so that's almost 8:30. Let's have a 10 minutes and then we come back. You have to check that application problems and remember implicit differentiation. Then we be done. It's very important quiz. The topics are a very good one. Okay, so don't worry if it takes times, but that give you good opportunity, to understand it, and not only on this quiz you'll be fine, also when we get to the next next test, because when you are out of this section it's going to be our algebra. We are not going to have any other formula, so go through this carefully and then you'll be fine. Okay, let's have 10 minutes. We come back and talk about those application problems. See you then. Okay, the next problem is going to be, there is one section, they talk about the marginal functions, you see in business or in application. The marginal means derivative. So if they, for example, they talk about the cost function, revenue function, okay, cost, revenue function, and profit function. So for this type of function, if they want to talk about derivative of the function, they refer to it as a marginal function. Okay, so this is just a kind of introduction to these functions. So if you have a marginal function, you can differentiate it. You know that derivative is going to be rate of change. So this is a kind of introduction of these functions. So I'm going to just generally introduce these three functions, and then we get these application problems. Okay, so this would be just give you a remark for number 4 and 5. Okay, that's going to be remark for number 4 and 5. Okay. So the remark is going to be, you see, we are going to introduce different functions. The first function that we're going to have is, you see, C of X. C of X is going to be the total cost function. The total cost function of, you know, producing or manufacturing of producing, okay, X number of, you know, whatever it is, okay, X number of whatever it's given, you know, units, we call it. Okay, it can be car, cell phone, etc. So if we talk about the C of X, this is going to be the total cost. C prime of X is going to be the marginal. Okay, this is going to be the marginal. That's the expression, the marginal cost function. So the term marginal in business means the derivative. Okay, so that's going to be the cost function, the C of X. The next function is going to be the revenue function. Okay, so the next function is going to be R of X. R of X is the revenue function. The revenue function. Okay, and it's going to be the same thing. And R prime of X is the marginal. Okay, the marginal revenue function. And eventually it's going to be rate of change if you like. Now, in order to get the revenue function, you see it's very, X is going to be number of the items. So for example, if you have, let's say 5 cell phone, and if your, the price, if you like, if the price of, you sell each cell phone for something like $200. So if you want to get your revenue, is going to be the 5 times the 200s. So that gives you the revenue function. Okay, so it's going to be always the case that if you want to find the revenue, you see, note that if you want to collect the revenue, is simply a number of items or units, whatever it is, you multiply by price of one item. Okay, unit price, we call it. Price of one item. Okay, so the equation that we're going to consider is going to be R of X is equal to, R of X is going to be X times P. It's a kind of lowercase p. Okay, so X is going to be the number of the item and P is going to be the price. So most of the time, this is your first job to find the revenue function. And we are going to use it, you know, in future quite a lot. Okay, so that would be the revenue function, and that's the cost function. Now the third function is the profit function. Okay, so P of X, uppercase P, is going to be the profit function. Okay, it's going to be the profit function. And of course, P prime of X is going to be the marginal profit function. Marginal profit function. Now, how are you going to find the profit function? You have to find it yourself in this case, and note that the profit function, you have to memorize this idea or this identity. The profit is going to be the difference between the revenue and cost. So it's going to be your revenue minus the cost function. So usually the revenue and the cost would be given to you. So you have to form this subtraction in order to get the profit function. So in order to get to the revenue, you have the X times P, the price, and the demands, they call it, the number of the items. Then in order to find the profit function, it's going to be Rx minus C of X. So the situation would be prepare and then be at this level. At this level, we would like you to be able to find these marginal functions, okay, the revenue, the cost, and the profit, and then evaluate it at some numbers for us, okay? It's get to know them at this level. But later on, we are going to, when we get to the next chapter, we are going to introduce the maximum and the minimum. So these problems are going to be something that we call it optimization problems. Optimization problem means you expect it to make a maximum revenue and you expect to have a minimum cost. So these problems come back again, but in different format, okay? So from now on, in each test or the quiz, you are going to have a couple of these type of problems, okay? So get to know them. You can have some other functions, growth function, decay function, but they are more popular and easier to handle. Okay, any question? So make sure don't know these expressions that I talk about it. And they may be given directly or you may have to find them. The way I construct these two examples are the one that we already talked about the cost. Remember, we give you C prime of 100 in your test. I graded 2 of problems of the test, but I finished it by the weekend. Since we already talked about the cost, so we are going to propose the revenue function and the profit function. Okay, for this quiz, we may give you both of them, or you maybe give you one of them. Okay, so this would be question number 4 and question number 5. Okay, so now we can go and see what is question number 4. Question number 4 is the revenue problem, we call it. Okay, this is going to be a revenue function in this question. And in question number 5 would be the profit function. The profit function. Now, in this case, the situation is going to be, okay, in number 4, I share it quickly. I may lose that camera, then I come back to it, but I have to share it so you can see the problem. Then we try to recover it again. Okay, can you see it? That is question
Yes.
number 4. I read through it and explain it, then I go and do it. Now, for this type of functions, they are not going to give you directly the revenue function. They are going to give you something, we call it price demand equation. It's going to be, you see, this is going to be the price and demand X, the number of the items. You know that the price would be, they decide about the price by, when the demand is high, they increase the price. Okay, so in this company market research department recommends the manufacture and marketing new headphone set for MP3 players. So they find out that the price demand equation, you see, for the revenue function, you have to check this expression. Okay, this is price demand equation. We always look for this one. Okay, this is P equal to the 10 minus 0.001x. P stands for the price and the X stands for the number of the items. So always look for this equation when we're dealing with the revenue function. Then what they ask usually, they ask you to form the revenue function. You know that the revenue is going to be the product of the price, okay, times the items X. X times P, P is given to you. You just multiply them together, that give you the function. They ask for the domain of this function. So you form the revenue function and its domain, then they usually ask the calculus part is marginal revenue. We know that the marginal means derivative. So we get that R of X, which is going to be easy function. We differentiate it, it's going to be R prime, and they give you 3 numbers. These are rate of change. They ask you to find these numbers and explain it. Remember, like the one that you did on the quiz for the class. Okay, so it's going to be number 4. So I get back to my notes and I take care of it. Okay, so this is how we handle the revenue problem. And it's going to be here, quite a lot, at least 3 more times. And these are the easy part of each quiz and the test. Okay, some people, they say, I don't like this. The word problem. They are not word problem. Everyday life problems and the easiest problem in calculus. So in each course, each test, you would do these problems really first because they are fixed problem. I cannot do anything about it. Okay, so for this type of problem, you look for the price demand equation. You see the price demand equation, P is equal to the 10 minus 0.001x. Okay, that's price, demand equation. So if the revenue function is not given to you directly, so you have to find it yourself. So the revenue function, as we talk about it, R of X, you see, is X times P. P is the price, X is the demand or the number of the item, XP. So it's going to be X times 10 minus 0.001x. You multiply it, so that give you R of X is equal to the 10x minus 0.001x squared. You see, this is going to be your revenue function. Easy to find. In the most of the problem that you have in your book, the revenue function is already given to you. Now, the point is, what is the domain of this function? Any suggestion for the domain of this function?
All real numbers.
Okay. Yes, in general, it's polynomial. So the domain is all real numbers. But remember, this is the revenue function. So there are some restrictions. First, this X cannot be any number because X is the number of the items, okay? So number of the cars, number of the headphones. So the number of the headphones must be a positive number. So X is positive. Okay, and there is another part. When you find it, it depends on the P2. P is the price. So the price must be also bigger than or equal to the 0. So this function is defined if X is positive and P is positive. You have a little bit of algebra to apply to get the domain of this function. You see, P, you have to substitute for the P to find out what's going to be the restriction that you're going to have. Okay, so your extra job is P is bigger than or equal to the 0. P is 10 minus 0.001x greater than or equal to the 0. You have to solve this one for X. Okay, so what we're going to do is, it's going to be negative 0.001x is greater than or equal to, you move the 10 to the other side, that give a negative 10. Then you divide by the coefficient of the X, which is a negative 0.001 to find the X. But since you divide by a negative number, you have to switch this sign of the inequality. So X would be less than equal to the negative 10 on the top. And this is going to be negative 0.001. Okay, any question? So we solve for X, the coefficient is negative. When you divide, you have to reverse the sign of the inequality. Now negative would be positive. There are 3 decimals here. You may put 3 zeros on the top or just use your calculator. So the result is going to be 10,000. Okay, so what you have is, so X must be less than or equal to the 10,000. So what's the domain of your function? You see X must be less than or equal to 10,000 and X must be greater than or equal to 0. So there you are. You have a revenue function, and this is the 10x minus 0.001 x squared. But X must be between 0 and 10,000. So if you like, the domain of the function is the closed interval of 0 and 10,000. This is the domain of the revenue function. Any question? And it's natural, you see, because when you do a business, X is the number of the items that you're going to sell or you are going to manufacture. So your line of production is not infinite. You cannot, produce infinity many numbers headphones. So there is a restriction. So this is the restriction. You can only manufacture, okay, or you can sell only between 0 and 10,000 headphones that you have in your, your store, if you like. So that is why, and this interval is going to be very important in future. Okay, in your book, the domain is already given. I just want to show you that to see how you are going to find it yourself, okay? And you have to do it for us in LibreOffice Algebra and give us the results right away. Any question? So that's the first part. You got the revenue function, okay? And there are two conditions. The items must be positive, price must be positive. But the price is 10 minus 0.001x greater than or equal to 0. You move the 10 to the other side of algebra. That give you quickly the domain of your function. Okay, that's the first part. This is the algebra part. That is part 1. Okay, question? Part 2, marginal revenue. Differentiate it. Okay, differentiate. It's going to be easy derivative because it's easy polynomial. But we got to be careful. You see 10x, the derivative of a 10x would be 10 minus derivative of 0.001x. You remember, exponent times coefficient. 2 times 0.001 is going to be negative 0.002x. Okay, 2x. Even if you use your calculator, make sure you get this one right. Okay, so our prime of x is going to be 10 minus 0.002x. This is what? This is the marginal. Okay, this is going to be the marginal revenue. Marginal revenue function. Any question? Remember, this is rate of change. It's the rate of change in your revenue. Then they give you 3 numbers and they ask you to evaluate it at those 3 numbers and tell us what's the meaning of those 3 numbers, okay? In this case, we have 2,000, 5,000, 7,000. These are the level of the production. Remember, you're selling headphones. So we want to know what would happen, if you do these type of numbers, okay? Any question? So we just substitute. Put x equal to the 2,000, 5,000, 7,000. Use your calculator, find the numbers and tell us what does it mean. Okay?
So how did you get the 0.002 again?
You see exponent times coefficient derivative.
Okay. So
Times.
squared it.
Okay.
Okay.
Again, double check it because this is going to be decimal numbers most of the time. Okay, so make sure that you get it right. Okay, so this is it. Let's find out now. 3 cases, x equal to the, so I just repeat that revenue, marginal revenue for myself. So R prime of x is equal to, okay, it's a 10 minus. I have 10 minus 0.002x. Now substitute one by one. We get x equal to the 2,000. X equal to the 2000. So R prime of 2000. R prime of 2000 is going to be 10 minus 0.002, okay, times 2000, times 2000. Okay, so this is going to be the case. Now you multiply 2 times 2 would be 4. It's a 4,000 and you have 3 decimals. Okay, so that give you, that's a 10 minus, okay, that would be 4. You can use your calculator to check it. 10 minus 4 would be 6. 6. So R prime of 2000, okay, R prime of 2000 is going to be $6. R prime of 2000 is equal to the, okay, 6,000. Okay, and there you are. What is the meaning of this one? Any suggestion? R prime of, remember the 2000 units are the MP3. Okay, so they are selling, for example, the MP3 headphones and they make money. That's going to be the one. So when you say R prime of 2000 equal to $6, what does it mean? Any suggestion? Remember, derivative is what? Derivative is rate of change. Derivative is the prediction. Remember, predicted rate of change. So what are you predicting over here for this number? You make $6 a unit when we make this one.
So you're making $6 a unit after 2,000 headphone sets?
Yeah, that's it. We have to give a level of production after, after selling, if you like, manufacturing, buying. After selling 2,000 units, okay, after selling 2,000 units, okay, the revenue will be increased at the rate of $6 per unit. So this means after 2,000, your revenue would be increased, okay? For each headphone that you're going to sell, you are going to make $6. Okay, rate of change in your revenue. You see, a rate of change in your revenue, $6 per unit. That's it. So the best way to write it down is you have to give us a level of production after, in this case, let's say selling a 2,000 unit, or you're manufacturing 2,000 units, the revenue, the company revenue, the revenue will be increased, okay, will be increased at the rate of $6, okay, per unit, or per what, in this case, per headphone. Okay, because they sell the headphone. Okay, this means you're making money. You're making money from now on. You just think about it. Are you going to continue or just stop? Is it worth it? Okay, are you happy about it or not? Question? That's case 1. Case 2, 5,000. So let's see what would happen if you are going to be at this level. Again, substitute. What's going to be R prime of 5,000? It's going to be 10 minus, again, 0.002 times 5,000 this time. You see, that give it 10 minus 10, which is equal to the 0. So in R prime of 5,000, you are going to make $0. Any suggestion? What does it mean? Any suggestion? At this level, at 5,000 units, you cease to make a profit. Yes, not bad. Yes. This means, yes, after selling, at 5,000 units, if you like, at the level of the 5,000, the revenue would be unchanged. Okay, you are not going to make any money. So this means when we get to the 5,000, you already make maximum possible money, if you like. You see, you get your maximum revenue. We are going to check this one in future. Your revenue would be maximum as 5,000. So if you continue after 5,000, you're not going to make any more money because you already got the maximum. Okay, so you can just use the same expression that we talk about it. So you have to stop, or this after again selling, manufacturing 5,000 units at this level of production units. The revenue, see, the revenue would be, you can say that will be unchanged. So you're not going to make any money. So at this level, you already got the maximum revenue. Okay, and this is the second problem I told you. When we get to the next chapter, you yourself, you let R prime of x equal to 0. See, this is R prime of x. You let it equal to 0, x would be 5,000. Then you are going to show that the 5,000, you get the maximum, but not now. Question? Let's see what would happen if you ignore this one and you continue the production. Okay, if you go to the level of 7,000. So what would happen into the R prime of 7,000? At R prime of 7,000, you get the 10 minus 0.002 times the 7,000. You see that give it 10 minus 14, which is a negative 4. Okay, so if you go on and just getting to the higher level of production, so this is going to be your result, negative $4. Any suggestion? What does it mean? Our revenue happened to be negative this time. So you lose, yes, that's it. You lose money. That's it. Charles, you lose approximately $4 every additional unit after 70. Yes, that's correct. You see, at this level, the revenue is negative. So this means at this level of production, you lose money. So your revenue would be decreased at the rate of $4, okay, $4 per unit. Okay, this means it doesn't work that to continue. Maybe your cost would be higher at this level. Okay, so after again, okay, after selling or at this level, 7,000 units. 7,000 units, the revenue would be decreased, or we lose money. Okay, will be decreased at the rate of $4 per unit. I see that give you the warning that at the stop, that's going to be the case. Okay, easy problem, but it's nice. Just give us something, we did all these problems, so what? So we'd like to put it into the practice to get these numbers. Okay, any question? So the profit function would be the same, but you have to find the revenue and the cost. So I want to get you one to the implicit differentiation. So I'll post the solution for number 5 for you. Okay, it takes more time to do it, but it's not bad. But I put the 5, so I like to give you the 6. Okay, we may not give you the 7. It would be too many questions. But we give you the 6. The 6 is implicit differentiation. It's easy one. Okay, so that's a 4. So I leave a space here for you. Then I will post the solution. I complete it, and then I post all of them again. So you are not going to miss it. So let me explain quickly this number 6. The idea of the implicit differentiation, remember? Implicit implicit differentiation. The idea of the implicit differentiation was all the function that you differentiated, y was given to you. You see, y equal to. But if a y is not given to you, it's going to be mixed together with x, we have to find it. Okay, in order to find it, we differentiate as we did before. You see, we did before means if you want to find the derivative of x to the n, because we're just using the power rule, it's going to be nx to the n minus 1. But when we get to the y, we have to apply the chain rule. You see, it would be n y to the n minus 1 times y prime. That's the only difference. To the power of the x is just ordinary one. Derivative of x fifth, 5x to the fourth. But if we get to the y to the fifth, it's like u to the fifth. It's going to be 5 y to the 4 times y prime. And then we solve for y prime. So that's a difference between these two. Okay, and we have two examples. The first one is just the power of the y, 2x cubed plus 3y to the fifth. Okay, equal to x to the fifth minus 2x. We want to find the y prime, differentiate it. When we get to the x, use this formula. When we get to the power of the y, use this formula. Means both of them are power rule, but you have to multiply by y prime when we get to the y. Okay, there you are. 2x cubed, 3 times 2, 6, 6x squared. That's for the x. I use this formula. Y, I have to use this one. Power again, the power part would be the same. 5 times 3, 15. 15 y to the fourth. But you have to pay for it, times y prime. Because y is a parenthesis. There is something inside the y that you don't have it now. So that's why you have to multiply by y prime. Okay, and the second part is just the same thing. 5x to the fourth minus 2. Now you have to solve for y prime. Solve for y prime. Solve for y prime is isolate the y prime part. 15 y to the fourth y prime. Move everything else to the other side. 5x to the fourth minus 2 and minus 6x squared. Then to find the y prime, you have to divide by the coefficient of the y prime, you see? The coefficient of the y prime is 15y to the fourth. So y prime would be the terms to the right, 5x to the fourth minus 2 minus 6x squared divided by the coefficient of the y prime, 15y to the fourth. And you're done. Okay, it's much easier than the other parts that we did. For this one, okay, because the y is a function, y is the u. Remember, when we get to u, you have to multiply by u prime. So in this case, we multiply by y prime. Then we solve for y. Okay, that's a type 1, a single y. The type 2, you have a product. This is a little bit more involved. Part B, 6x cubed minus, okay, 5xy plus y to the fifth equal to 2xy minus 1. This type 2, sometimes you have to apply the product rule as well. So there must be a misprint somewhere here because they shouldn't be 5xy and the 5xy. Okay, so I changed one of them. Suppose this is going to be, okay, suppose this is 5x squared. Okay, probably this is, I change it when I renew it for you, okay? So it would be to match. So this is going to be the actual one. I have to check it again. So it's going to be 6x cubed minus 5x squared y plus y to the fifth equal to the 2x minus 1. That's the actual one. Now we differentiate. Again, the same thing here. You see the first one, 3 times 6, 18. 18x squared. Done. Now the tricky one is this one. You see this is a product of two functions. The first function is 5x squared. The second function is y. So we have to apply the derivative of the first times second, second first. So the first one's going minus 5 times 2, 10, 10x times y. That's the derivative of the first times second, plus the second first. But there is a negative sign here. It's going to be negative. Second, derivative of y is y prime. So it's going to be y prime times first, 5x squared. Okay, so you have to apply the product rule as we did it before. Derivative of the first times second, it's a 10x. Second first, derivative of y is y prime. Then plus derivative of y to the fifth, 5, y to the fourth, but you have to pay for it, y prime, you see? Anytime you differentiate respect to the y, use the chain rule. Anytime you differentiate respect to the x, it's just the ordinary one. Okay, we go to the other side, derivative of the 2x is 2 and derivative of 1 is 0. Then we have to solve for y prime. Solve for y prime. So we keep the y prime one side. This is one of them. Okay, I rewrite it as a negative 5x squared y prime. And I have this one plus 5y to the fourth y prime. Move everything else to the other side. 2 minus 18x squared plus 10xy. Okay, the y primes, you keep them in one side, the x is on the other side. Now the difference is going to be you have 2 y prime here. You cannot add or subtract it. So you factor out the y prime because you need the coefficient of the y prime, okay? So there you are. You can rewrite as a negative 5x squared plus 5y to the fourth, y prime out. Okay, doesn't matter to the right or to the left. And this is going to be 2 minus 18x squared plus 10xy. So the y prime would be the term to the right, 2 minus 18x squared plus 10xy divided by the coefficient here, negative 5x squared plus 5y to the fourth. That is implicit differentiation. So it's a 2 times. We give you 2 parts. The first part easy, just 1 power of the, you see, y to the fifth, y to the third. But the other one, you have to use the product rule over here. Okay, that's number 6. And number 7, it's too much. We keep it for the next test. Okay, so not difficult, but we keep it. So 6 questions. Okay, as I told you, it's very dense topics or the dense quiz, but it's not bad because you have to practice to make sure that you are able to do this one on the test. Okay, so this is going to be the case. What question? The marginal cost is more than the marginal benefit. What do you mean? No, the marginal cost is just C of X. You see, in order to get the profit, you see, C of X is the marginal cost. In order to get the profit is the difference between the revenue and the cost. Okay, we have the revenue. We have the revenue, what you sell, that's going to be your revenue. But your revenue is not going to be your profit because you have to subtract the cost to get these numbers. Okay, how did I get 5x squared times, what's that? This is, I use the product rule. I change it, you see the question was, the question must be this one. Because in the given question, I will change it right away and I repost it for you. Because in the question, you have 5xy and the 5xy doesn't make sense, you see. If you have 5xy here and the 5xy here, you can cancel it out. So there was a misprint on that question. So this must be the actual one. 6x cubed minus 5x squared y. Okay, any question? So I post the number 5 for you. That's the profit one. Yes, question.
I have a question, like for number 1E, how will you solve it if the bottom had a power, let's say 3? Because last time,
1e.
yeah, sorry. Because last time I got a little confused when there was like a power of a different, like had a power.
Oh,
So
then you have to use the formula. You see, this is you just change your formula for the index of the radical. You see, this is the one that you're talking about. You see,
Mhm.
so this is 2, so that would be 1/2. If it's
Okay,
going to be 3, that would be 1/3.
Oh, I see. Okay.
Remember the formula
Yeah.
that we talked about it? The
Yeah.
n root of x is x to the 1 over n. So it depends on the index of the radical. Okay, yes, any more question?
Just to clarify real quick, so for 2B, 2D, and 2G, we would use the quotient
Quotient
rule.
rule,
for
yeah,
those.
they are very
Okay.
the same as the A, even they are easier.
Okay, thank you.
Okay, that's fine, yeah, I can post solution of those one too. When I complete this one, I add the 5 to this one, and those the one that I didn't do one, what was that? Yeah, B, D, and G. Then I will post all of them so we can check it. Okay, I'll do it tomorrow, and then I post the entire solution so you can have it. So get that take-home one. It's a very good one. That take-home is very similar to what I did tonight. So that would be good for you to practice. Okay, that's it. So check your assignment and the take-home one, and be prepared for this, this quiz. Okay, have a good one.